Hello, this is Mr. Gilmore with the 2.6 Indirect Proof lesson. Today we're going to be looking at the power of what an indirect proof is. What we'll find is that there are some cases in which a direct proof, which is what we've seen already, where we have a sequence of statements carrying us from the given to the conclusion, it may not be possible for us to reach into the conclusion there from the given, which is why we're going to look at the power of what's an indirect proof. Now, before we actually look into the insides of an indirect proof, let me tell you a little story. So here's a little story. It goes like this. There can't be an opposite day, he said. If there were, it would be the opposite of opposite day on opposite day, since everything is opposite on opposite day. But the opposite of opposite day is just a normal day. So if there were an opposite day, it would really just be a normal day, and that's impossible. What you just heard there is actually a little story that unfolds into an indirect proof. Let's break down the structure of this proof. If we take a look, we started by stating a conclusion, such as there can't be an opposite day. Well, what did we assume then? We assumed the opposite of that statement. So if I want to prove or conclude that there can't be an opposite day, then let me assume that there can be an opposite day. But we find then in the middle of that statement, in the middle of that little story, that we reach a contradiction with our assumption. The contradiction led us to that the opposite day would really just be a normal day. And they can't be both the same thing. If it's opposite day, it cannot be a normal day, and a normal day cannot be opposite day, which means we've hit a contradiction there. And so, because we've hit a contradiction, we may then assume or take that assumption and declare it's false, which means we can state what it is we were to prove, which is that there can't be an opposite day. So what did we just do? We actually looked at an indirect proof there. Here are the 5 parts of an indirect proof. The 5 parts are broken down as this: the given, the prove, the assumption, the reduction, and the conclusion. Now, we're familiar with the given and prove statements. These are the ones in which we start off with the information given, and the prove statement is what our conclusion is. But what follows the proof statement is this next step that leads us into an indirect proof, and that is the assumption. The assumption is the negation of what it is we want to prove. Now, we're familiar with that word negation. We saw that with our related conditionals. So let's say I wanted to prove that the pizza is cold. Then my assumption would be the pizza is not cold. I would negate that statement. Then the reduction. Now, the reduction is where the power is. And I'll explain more about that in just a minute. But the reduction is what we're going to basically state or prove that there's some sort of contradiction because of our assumption. And because of that contradiction, that's going to lead us then into our official conclusion. And that is where we reject what we assumed. Basically, in an indirect proof, we're removing all other possibilities except for the one that it has to be. So, a contradiction, yeah, this is where the real work of the indirect proof is. This is the leverage that's going to carry us into the into proving that the proof is true, right? That this our conclusion of what we are to prove is true, because we're going to have some sort of leverage in form of contradiction, and that contradiction is going to contradict something that we know. Well, what are things that we know? Well, we've been studying these postulates, definitions, theorems, even, and of course the given. It may even actually contradict what we are given in a scenario. So let's look at another example. So our first example, right, we saw was we broke down the proof that there's not an opposite day. But let's look at another example here. So let's prove that if n squared is odd, then so is n. So n is some n squared is n is an integer, and so when we square it, it's odd. Now let's prove that n, the integer, is also odd. So we're given that n squared is odd, and we're going to prove that n is odd. Well, our assumption then, remember, is the negation of the proof statement. So our assumption is n isn't odd. N isn't odd. Well, if we call, now this is where the power begins. We begin to approach some sort of contradiction in our reduction phase. So now we're going to reach some sort of contradiction based on our assumption. So since we've assumed that n isn't odd, then I can call it even. right? That integer must be following one of those two buckets, an even number or an odd number. Well, if it's not odd, it has to be even. But if I were to square that even number n, a square of an even number is itself even, which means I'm saying that n squared is even. But that is a contradiction to our given. We're given that n squared is odd. And thus, if we assume that n isn't odd, we will reach a contradiction in that. So we have to toss out our assumption. So in our conclusion, we reject the assumption. So it's false that n isn't odd. It must then conclude that n is odd because we've removed all the possibilities of with contradictions. Because if we made n even, well, then we'd have a contradiction. So thus n is odd. And that's really the power of an indirect proof. Let's look at one more. We got a third example here to finish off our lesson. Let's prove that if angles A and B are supplementary, then not both are obtuse. Right? Then not both angles A and B are obtuse. So in our given, right, we're given that angle A and angle B are supplementary. And we're going to prove that not both A and B are obtuse. Well, we assume the negation of that statement. So if we want to prove that not both, then let's assume that both angles A and B are obtuse. Now we know, and now here's the power of our reduction, because we're going to reach a contradiction. Now we know that if we were to say that angles A and B were obtuse, we know the measure of obtuse angles are greater than 90 degrees. Which means if we were to add the two angle measures together, angle A plus angle B, we're adding two measures that are greater than 90, which means their sum is going to be greater than 180. But that is a contradiction. It contradicts the given. Because in the given, with two angles being supplementary, their sum is equal to 180. But based on our assumption, we said that it was greater than 180. And by the law of trichotomy, we cannot then go against having two of those being a possibility. It must be only one. So that's where we find a contradiction. We contradict our given that the two angles must equal 180 and not be greater than 180. So we reject our assumption. So we assume that both were obtuse. Now we reject that. So not both are obtuse. Now, as you jump into the 2.6 worksheet, you're going to explore many other indirect proofs. Do the best you can. And if you do have any questions, email me. I would be happy to get back to you. With that, be good and do good.